Imagine a boat is crossing a river from one bank to another. It's moving in the direction perpendicular to the flow of the river. Tell me, will the boat reach the bank at this place P or somewhere to the right of it? That's right. The boat will reach the bank somewhere on the right side of this point P. We know that the motion of the boat is also influenced by the velocity of the river along with the velocity of the boat's engine. So, the boat actually travels with a different velocity, which is the resultant of these two velocities. If vector v1 represents the velocity of the boat's engine and vector v2 represents the velocity of the river, then the boat's velocity v3 will be the vector sum of these two velocities. And what will be this vector v3? Let's find out. Let's say this arrow represents vector v1, the velocity of the boat's engine. We know that the river's velocity is perpendicular to v1. So let this arrow represent the river's velocity v2. Now we know intuitively that the vector v3, which is the boat's actual velocity, will be somewhere in between these two vectors. But how can we find it accurately? Actually, to find the vector v3 precisely, there is a law of vector addition called the Parallelogram Law of vector addition. Now let's suppose that we have a parallelogram, and the two adjacent sides of it represent the two vectors a and b in magnitude and direction like this. Then the sum of the vectors a and b is represented in magnitude and direction by the diagonal of the parallelogram through their common point. This is known as the Parallelogram Law of vector addition. Take a moment and have a look at it. Now let's get back to our example. Can you apply this law here to find the boat's actual velocity v3? For this, let's draw a line segment parallel to vector v1 here and similarly a line segment parallel to vector v2 here. So since v1 and v2 are perpendicular to each other, we get a rectangle here. Now, according to the Parallelogram Law of vector addition, this diagonal will represent the vector v3. We can find the magnitude and the direction of the vector v3 by using the geometric properties of this rectangle. So, in this way, we can apply this law to find the vector sum of two vectors. Now suppose we are given these two vectors c and d whose initial points are not the same. Can you find their vector sum? For this, we will just have to move one of the vectors parallelly without affecting its magnitude and direction such that the initial point of both the vectors coincide. If we move vector d, then we will get this. Now, we draw two lines parallel to vector c and d to form a parallelogram. Then, according to the Parallelogram Law of vector addition, this diagonal will represent the sum of the vectors c and d. But now wait. In the previous video, we saw that the sum of two vectors is given by the triangle law of vector addition. Here, according to this law, we move vector d such that its initial point coincides with the terminal point like this. So we see that these 3 points, A, B, C, will form a triangle. Now the third side of the triangle in the opposite order than these two represents the vector sum of these two vectors. Thus, we have two laws for vector addition. Which one should we follow to find the vector sum? Actually, both the laws give us the same resultant vector. These two laws are equivalent to each other. We will see this in the next lesson. Here, we saw how to add vectors. In the next lesson, we will also look at how to subtract two vectors. To stay updated and to keep learning such interesting concepts, do subscribe to our channel.